To learn how to control an iPhone's main view, you need to learn about working with windows and views. iPhone apps have a single window, so you won't find separate document windows for displaying content. When your app is running, and even though other apps may be hibernating or running in the background, your app's interface takes over the entire screen. The single window that you see displayed on the iPhone is an instance of the UI window class. As you can see here, I've selected the main window in the interface builder and then selected the window. It's the UI window class. This window is created at launch time, either programmatically by you in your code or automatically by UIKit, loading it from a nib file. That's exactly what we're doing here with this template. We're using a nib resource file with interface builder, and UIKit loads it in. We can now add views and controls to the window. In general, after you create the window object, that is, if you create it instead of having it done for you in a template like we did, you never really have to think about it again. Now, a user can't directly close or manipulate an iPhone window. It is your app's code that programmatically manages the window. And although your app never creates more than one window at a time, iOS can support additional windows on top of your window. The system status bar is one example. You can see it here with the battery icon. You can also display alerts on top of your window by using the supplied alert views. In an iPhone app world, view objects are responsible for the view functionality in the modal view control architecture. A view is a rectangular area on the screen on top of a window. The content view is that portion of data and controls that appears between the upper and lower bars, the toolbar and the navigation bar, as you can see here. So it's really the frontmost view. In the UIKit framework, windows are really a special kind of view, but for purposes of this discussion, we're talking about views that sit on top of the main window. Views are the main way for your app to interact with the user. For example, views display content. This happens by making drawing and animation happen on the screen. In essence, the view object displays the data from the model object. Views also handle touch events. They respond when the user touches a button, for example. Handling touch events is part of a responder chain, as I showed earlier with the first responder object in the interface builder. There's also a hierarchy to the view, with views and subviews. You have two ways of looking at it. Visually, which is how the user perceives it on top here, the content view, and programmatically, which is how you create it, the bottom part here. Looking at it visually again, the window is at the base of this hierarchy with a content view on top of it, which is a transparent view that fills the window's content rectangle. The content view displays information and also allows the user to interact with the application using interface items such as text fields, buttons, toolbars, and tables. Now, in your program, that relationship is different. The content view is added to the window view as a subview. Views that are added to the content view become subviews of it. Views added to the content view also become the supervisors of any views added to them. And a view can have only one superview. It seems counterintuitive, but a subview is displayed on top of its parent view, that is, on top of its superview. Think about this relationship as containment. A superview contains its subviews. Controls, such as buttons, text fields, and so on, are really view subclasses that become subviews. So are any other display areas that you may specify. The view must manage its subviews as well as resize itself with respect to its superview. Unfortunately, much of what a view does is already coded for you. The UIKit framework supplies the code that defines view behavior. But the view hierarchy also plays a key role in both drawing and event handling. When a window is sent a message to display itself, the window asks its subview to render itself first. If that view has a subview, it asks its subview to render itself first, going down the structural hierarchy or up the visual structure until the last subview is reached. It then renders itself and returns to its caller, which renders itself, and so on. You'll see this as we add code to add subviews to the main view. You create or modify a view hierarchy whenever you add a view to another view, either programmatically or with the help of the interface builder. The UIKit framework automatically handles all the relationships associated with the view hierarchy. The UIView class defines the basic properties of a view, and you may be able to use it as is, as we do in the My Worlds app, by simply adding some controls. Now remember, it's important to use the view objects that are a part of the UIKit framework. When you use an object such as UI slider or UI button, your slider or button behaves just like a slider or button in any other iPhone app. This enables the consistency in appearance and behavior across apps that users expect. So the framework provides you with a number of other views that are subclassed from UI view. These views implement the kind of things that you as a developer need to do on a regular basis. For example, a container. Container views are a technical Apple term for content views that do more than just lay there on the screen and display your controls and other content. For example, the UI scroll view class adds scrolling without you having to do anything. UI table view inherits this scrolling capability from UI scroll view and adds the ability to display lists and respond to selections of an item in that list. You see this kind of thing in action in the Contacts app that's supplied with the iPhone and a host of others. Another container view, the UI toolbar class, contains button-like controls which you can find everywhere on the iPhone. In Mail, for example, you tap an icon on the bottom toolbar to respond to an email. Now, controls are the fingertip-friendly graphics you see extensively used in typical apps' user interfaces. Controls are actually subclasses of the UI control superclass, which is a subclass of the UI view class. They include touchable items like buttons, sliders, and switches, as well as text fields in which you enter data. Controls make heavy use of the target action design pattern, which you see with the Done button in the flipside view. Display views are like controls that look good, but don't really do anything. These include UI image view, UI label, which we will soon use in the My World app to display an area for the following words to appear, and others like UI progress view and UI activity indicator view. There are also text and web views, which provide a way to display formatted text in an app. UI text view class supports the display and editing of multiple lines of text in a scrollable area. UI web view class provides a way to display HTML content. These views can be used as the content view, or they can be used in the same way as a display view, that is, as a subview of a content view. UI web view is also the primary way to include graphics and formatted text in text display views. Alert views and action sheets present a message to the user along with buttons that allow the user to respond to the message. Alert views and action views are similar in function, but they look and behave a bit differently. For example, the UI alert view class displays a blue alert box that pops up on the screen, and the UI action sheet class displays a box that slides in from the bottom of the screen. Navigation bars and tab bars work in conjunction with View Controller to provide tools for navigating in your app. Normally, you don't need to create a UI tab bar or a UI navigation bar directly. It's easier to use Interface Builder or configure these views through a tab bar or navigation bar controller. Finally, the window provides the surface for drawing content, and it's the root container for all other views.